section 2.2 in your book begins on, I'll tell you what page. 62, yes. If you want to follow along in your textbooks. We're talking today about complement subsets and Venn diagrams, and just a little bit about Venn diagrams, not that much about Venn diagrams. So we need some definitions. The complement of a set A, denoted by A with that little I can't think of the word today. Little line up there, is a set of all the elements of the universal set U that are not elements in A. Whenever you see U, U is going to be the set of everything that you are allowed to choose your elements from for any sets you're writing down. So these are everything in U that is not in A. In other words, everything outside A. So when you see complement, think outside A. So everything outside our set A. That's our complement. A subset of A is any set B having the property that every element in B is also an element of A. And we denote this as B is contained in A. So if I had A was a set 1, 2, 3, 4, and B is a set 1, 2, and 4 maybe, then I know B is a subset of A. And I can write that without that little line under there because B is missing an element from A. So it's strictly contained in A. If I wrote this as C was equal to 1, 2, 3, 4, that's a 2, then I know that C is contained in A, and I can write that line underneath because C is also equal to A. So that's the difference. You can always write the containment symbol with the line underneath because it doesn't have to be equal for it to work. But if I write it without the line underneath it, then you know that it's missing something. It is a proper subset. Okay, those are our definitions. The complement of the universal set is an empty set. So the opposite of everything is nothing. The opposite of nothing would be everything. Keep those in mind. Those are going to be useful for us. And then the complement of, we already said this one, complement of the empty set is universal set. And then A can be a subset of itself, and the empty set is a subset of every set. Okay? A is a subset of itself. This is true since A equals A. And this second one is true since the empty set contains nothing. So it's a subset of every set. Those are just some things to memorize, keep in your mind as we're going through. It'll make the rest of this chapter easier if you remember those remarks. If you forget them, you're going to keep looking them up because we're going to come back to them. So make sure you learn those. Let's do some examples. Our universal set is going to be the numbers 1 through 10. S is going to be the set 2, 4, 6, 7. T is going to be the set of all x less than 10. Oh, there should have been a space here. And right there. When I'm typing in math mode, it doesn't put spaces in, and I didn't get the spaces put in for it. Anyway, x is less than 10, and x is an odd counting number. If x is an odd counting number and x is less than 10, what does this set for t actually look like then in roster method, listing it? Mm-hmm. 1, 3, 5, 7, 9. The counting numbers start at 1, and these are odd counting numbers smaller than 10. So 1, 3, 5, 7, 9. Now let's come down here, and I'm going to do number 2 first because we calculated t. What is the complement of t? It's everything in U that's not in t. So let me cross off the things that are in t, and then write down the things that remain. That's as easy as it gets. So I'm going to erase these guys so that I can do number 1. Find the complement of S. Our first step is to cross everything off that's in S. And then write everything else down. Can you do that? Now you're going to get some problems that have like a whole bunch of different things, and as we go on through the sections, you'll see what I'm talking about. We're going to get unions and intersections and complements, and they're all going to be grouped together, and you're going to try and skip steps. That's when you get your answers wrong. So write each part of your work down and use that for the next part. You won't make mistakes that way. This is not that difficult to do if you don't try and skip steps. If you start skipping steps on it, you're going to start getting it wrong, and when you start getting it wrong, then you think you don't know what's going on, when in actuality you do. So don't skip steps. Any questions on this? Okay. You get to do one. Let's put our spaces in here. Goes on the quiz sheet, the one with your name on it already, hopefully. And you can just call it checkpoint 1. Remember, when you have it finished, compare your answers with your neighbors. Everybody should have the same answer. You should get the same work from everybody. Okay, I think everybody has that finished. So let's go through some examples here. It says determine whether each statement is true or false. Remember, when you're telling me true or false, you're going to write the entire word out because some T's look like F's. So look at the first one. It says the set 5, 10, 15, 20, is that a subset of 0, 5, 10, 15, 20, 25, and 30? Remember, this symbol means all of these guys over here have to live over here someplace. So I have 5 lives over there, 10 lives over there, we have 15, we have 20. This guy has a couple more elements in it, but that doesn't matter. It's the bigger set. So I can write this as true. Okay? Everything in the first set on the smaller side of the containment symbol is contained in the bigger set. So that would be a true statement. The next one. W is contained in N. W is a set of whole numbers. What are the whole numbers? Ah, you guys remembered. 0, 1, 2, 3 goes off to infinity. Set of the whole numbers. What are the natural numbers? Is everything in W in our set N? In fact, which element isn't? 0. So this would be false. Our containment should go the other direction. Tell me about number 3. We have 2, 4, 6 on the first set. We have a 2, a 4, and a 6 on the second set. True. It's true because we have the line under it. That's what makes it true. How about number 4? The empty set is a subset of 1, 2, and 3. True. It's a remark. Yeah. That's true. The empty set is a subset of every set. The empty set is a subset of every set, because it contains no elements. So everything that it contains, which is nothing, is part of any set that you could write down, because it doesn't have anything in it. And then the last one, this one's kind of strange. A equals A complement complement. I hear some people saying true, and the answer is actually going to be true. Let's see why. If we make U just to make a set, and I'm going to make A be the set, 1, 2, 3. What is A complement? 4 and 5, yep. You cross off the 1, 2, and 3 from U, you're left with 4 and 5. Now, what is A complement complement? Yep. A complement complement is equal to A. This is just like multiplying a -1 by a minus sign. What does that give you? 1. The two minus signs cancel. Complements and minus signs mean essentially the same thing in their different areas of mathematics. Complements are dealing with sets, minus signs are dealing with numbers. We can treat sets just like we treat numbers. I teach an abstract algebra class this semester, and we are doing algebra with sets instead of with numbers. Same type of stuff that we do with numbers. You do addition and subtraction, multiplication. We don't exactly do division. But you can do that with sets too. You just define your operations a little bit differently. Any questions on these true-false questions? I should write true here. Okay. A proper subset. Set A is a proper subset of set B, denoted by A is contained in B. There's no line under here. If, can't spell. If every element of A is an element of B, and A is not equal to B. So if every element of A is an element of B and A is not equal to B, then I have A as a subset of B, a proper subset of B. In other words, suppose that B is going to be the set, I don't know, smiley face, a star, oh, let's do a frowny face and a capital D. I'm going to make A be smiley face, and star. And I'm going to make CB 1 and capital D and a smiley face. What I want to know, I need one more set for my example. So first of all, tell me about the relationship A and B. Is A a proper subset of B? Yes. So I can write it this way. I can also write A and put the line under it. Both are correct. Now, tell me about C and D. Is C and B? Is C a proper subset of B? Is every element in C an element in B? No. So here I would put a line through it. It's not a subset. And it's also not using the line under it because it's not equal to B. Then let's look at the last one. Tell me about E and B. Is E a proper subset of B? Is there anything extra in B? No. I can't use that proper subset symbol. However, I can use the subset symbol with a line under it since I know that E equals B. You guys see the difference there? No line under your subset symbol means that the bigger set has extra elements. So if I'm looking at just some subsets K and W, that says every element of K is in W, and W contains something extra. Oh, that's horrible writing. W contains something extra, not in K. That's when you use the symbol without the line under it. Any questions on that? It's probably a little bit confusing in mathematics. Let's look at examples. For each of the following, determine whether the first set is a proper subset of the second. In other words, can I put this symbol right here? Is that a true or a false statement? The first set, what's in your first set? A, E, I, O, U. How about the second set? Yeah. So you would actually have to put the line under it so it's not a proper subset. Because it says determine if it's a proper subset. It's not a proper subset since they are equal. On number 2, the natural numbers and I, where I is a set of integers, n is a set of natural numbers. So, tell me, is the natural numbers a subset of the integers? The integers contain what? Negatives, 0, and positives. What do the natural numbers contain? Positives. So, yes, there are extra elements in I. Everything in n is in I. So this is a proper subset. So that one is. The first one was not because they were the same sets. They were equal. Any questions on that? Okay. You guys get another checkpoint. You don't actually have to copy the entire problem down. I give the grader the problems typed up so the grader has them. See up here on the board? It's the tiniest little clothespin. Have you seen a clothespin that small? Never seen a clothespin that small. That is a tiny little clothespin. I don't know what it's doing up here, but Cute little thing. A Barbie doll clothespin. Remember, the bigger set has to be on the side where the symbol opens to. The bigger set's on the side where the symbol opens. So, what did everybody get? False. Why is it false? The bigger set's on the wrong side of the symbol. The bigger set has to be on the side where the symbol opens. So this one is false. We good with that? So many new symbols. Hey, let's look at another example. It says that C shows the 4 condiments that a hot... Maybe this is a veggie hot dog. A hot dog stand offers on its hot dogs. You have mustard, ketchup, onions, and relish. I'm guessing they aren't a hot dog stand here at Southern because they offer mustard. Or do they offer mustard in the cafeteria yet? They do now? Okay, that's a new thing. When I got here 9 years ago, they didn't. Okay, so mustard, ketchup, onions, and relish. List all the subsets of C. How many subsets are there? So, I am going to call M for mustard because I don't like to write, K for ketchup, O for onions, and R for relish. And so I'm going to just start listing these. We have the set with just one element in it. It's M, K, O, and R. One element each. And each element gets to be in a set. Now I'm going to list all the subsets of 2 elements each. So I'm going to do M and K, M and O, M and R, and then I'm going to do K and O, K and R, and then I'm going to do O and R. And that's all the sets with 2 elements. All combinations of 2 elements. Does that make sense? I'm just forming combinations here. And now I'm going to form combinations with 3 elements. So we have MKO, MKR, KOR, and I think that's it. Oh yeah, we forgot that one. M, O, and R. That should be it then. And then, so these are 3 elements. And then we're going to do the one with 4 elements. There's only one of them. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm missing one. Which one am I missing, guys? It's one of the 2 ones, or one of the 3 ones. Oh, I should have 16 of them. M, K, M, O, M, R, K, O, K, R. I have that one right there. That's the first one. Maybe I miscounted them. I should have 16 of them. Let me double check. This is an example in the book rather than me standing here trying to figure this out. MKO, MKR, MOR, AOR. Oh, I am missing one, but it's the obvious one. It's the empty set. I totally forgot about that one. We had everything else. We missed the easiest one, the empty set. The empty set's a subset of every set. Remember I said that at the beginning? And I remember I told you to come back to haunt us? Already it did. I forget about that set all the time. So there's our empty set. That's all of them. How many of them are there? Yeah. Now, how many of those subsets are proper subsets? Which ones are proper subsets? They're everything except the one with 4 elements in it, the one that's equal to the original set. Yep. I want you to notice something. 16 I can write as 2 to the 4. 4 is the number of elements in our original set. And then 15 is equal to 2 to the 4th minus 1. Here again, 4 is the number of elements in the original set. That's how I knew there was supposed to be 16 elements, 16 subsets. That's where I knew that from. Now, if I gave you a set with 10 elements in it, you're not going to want to write them all out. But we are going to need to know how many subsets there are. And we're especially going to need to know this when we get into, I think it's chapter 10 when we do probability. We're going to need to be able to count the number of subsets. We're going to come back to talking about sets at the end of the semester. So keep this rule in mind. It's going to come back to us. And all we have to do is to be able to find out how many subsets there are. So a set with n elements has 2 to the n subsets, and it has 2 to the n minus 1 proper subsets. That's all we need to know. Memorize this. Memorize it for keeps, because we're going to need it again at the end of the semester. That's an S. So memorize that formula, write it down, memorize it, highlight it, carry it on a note card with you everywhere you go. That one you have to have memorized for the rest of the semester. I think everybody's pencil stopped moving almost. You guys get to try one. Compare your answers. No, just write how many subsets it has. You don't need to list them all. How many subsets does it have? Compare your answers with your friends when you're done. for proper subsets on this question, guys? No. I just asked you for subsets, so you know that first formula you wrote down? Don't subtract 1 from it. So what should you have for your answer? 2 to the third. There are 3 elements in this set, right? So 2 to the third is what? 8. Don't subtract 1 and tell me 7. That's the number of proper subsets. I just asked you for subsets. So it's just 2 to the third, which is 8. Okay. We are done for today. Make sure your names are on your quiz papers and that I get your quiz papers up here before you leave. Don't walk out of the room with your quiz papers.